Okay, I'm going to give you a few questions that you need to come to class having answered after reading this paper. So in addition to the message box, I'm going to give you some advice on how to read this paper and how to organize your thoughts. Make sure that you actually write out the answers to the questions that I am posing to you here. So start at the beginning. As you read this, you're going to need to be super active. There are a lot of moving parts here. It's a little complicated. So start off by um, making yourself a list of known information about the two variants that they talk about. They talk about 127 and 129. So get yourself a list and anything that they say about one of those. Okay, first of all, they're going to say they're reporting a novel protein or protective prion protein variant, G127V. So now you know that G127V is novel. It's reported for the first time in this paper. They've got something next about 129 here. So write down whatever this says about 129. Next, I want you're going to keep that running as you're reading. I also want you to have a running timeline of Kuru. Okay, they're going to tell you um, a whole bunch of information about Kuru. So very early on, they're going to say the first cases appeared in the early 20th century. Write that down on your timeline. In fact, they give you little pieces of information about Kuru throughout this, and actually what I did is I just went and looked up a timeline also. So you can use information from here. This is at the Royal Society Publishing.org. You can probably see it up here if you want to go to it yourself, or you can just look at it right here. But what are you seeing? Uh-oh, you're seeing nothing now. You're seeing that the heyday for this, the greatest number of deaths is right here in 1957 is when it starts, and it goes, just gets progressively smaller over time. But the heyday is really in the 1957 to 1961. With the last cases being somewhere in the 2000s here. They separate out males and children, right? Kids less than 20 years old, and then females are going to be up here. And so you already know probably that the females were the most exposed. Okay, so you've got a timeline, you've got your list of information about the two different variants, and then there's going to be a table in here that you're going to want to annotate like crazy. So let me show you this table. This table here breaks out the population into, if you're just looking on the left-hand side, into patients with Kuru, into inhabitants of the Eastern Highland Province, and then they break it out into women versus men, and then ages, right? So people born before 1950, born before 1950, and living in high exposure areas. What do those populations mean? Which of these populations were highly exposed and which were not? Which of these populations would experience the strongest selection? You want to annotate this table like crazy. So in addition to annotating the populations and why they're being included and separated out in this study, you also want to annotate, we already said G127V, this is your novel variant, okay? Which of these is a protective genotype and which is not? We want to annotate that. There's something else on here I wanted you to annotate. Oh, okay. So which of these people are likely to be resistant and which of these people are children of resistant adults? So you want to put that down. Okay, then there's one other thing that you're going to need to know ahead of time, and that is that they give you a series of hypotheses, and that is going to be back one page. Let's go back to that. They have their hypotheses right here. They wanted to know if this variant, G127V, is a neutral polymorphism, a novel pathogenic mutation causing a prion disease, or if it is a polymorphism that confers resistance to the disease. So these are their hypotheses down here. Write those hypotheses out, make some predictions. Now that you know the populations they studied, if this variant is neutral, what allele frequencies do you expect to see in populations that had the greatest levels of Kuru versus no Kuru? What do you expect to see in modern populations versus people born before 1950? Do you expect to see differences in males versus females of different ages? And you're going to want to make these predictions for each of these hypotheses. And then as you go through the paper, you're going to write down what do they actually find. So which hypotheses are they supporting? And that's where we're going to really jump off in class and start talking is which hypotheses have the most evidence and which do they not do a very good job of refuting, right? So what's remaining in your mind? There's something else in this little paragraph here that I wanted to point out, and then I'm going to give you a couple definitions and we'll be done here. In parentheses here after G127V, they tell you C.380G to T, and then they have CCDs and a number. If you just type in CCDs and that number, that's going to take you to the GenBank page for that. Here we go. Actually, I need to go back. It's going to take you to the GenBank page for the consensus. Find my notes on this. The hold on. Where do I have these notes? Okay, there we go. For the consensus coding sequences, right? You can see that this is the species it's found in is Homo sapiens. It's on chromosome 20. The gene, right? PRNP, we know that. And then every time it's updated, you get a new record in here. You can follow links to see the history. You can follow this link here to look at the gene. That's the one I'm going to go to. You can follow the link here to just look at the consensus coding sequence. You can follow this link here to look at it in the sequence viewer, which will give you an annotation on chromosome 20 also. I just went ahead to the gene. That's where I tend to look. So this will give me information about the gene. This is its official symbol and its name, prion protein. It'll tell you where else you can go to find information about it. Ensemble will have some information about it, for instance, found in Homo sapiens. This is your scientific path, right? Lineage to get to Homo sapiens. It's going to summarize up where it's found, 20 kb upstream of a gene encoding for blah, blah, blah. It's going to talk about Creutzfeldt-Jakob and so on. Then what's really cool is you get down in here and it's going to show you, right, the chromosome. It's going to show you the position on the chromosome. PRNP is located right here. And then a little further down, it's going to show you where any known variants are found. And you can click on those and then go to the report for that variant. So it may not actually take me to the report right now. So this is a SNP, a single nucleotide polymorphism, and it's going to tell you where it is. Here we are. This is a C versus a G at this position. And it looks like this is position 141. So I bet we could scroll back a little bit and we could try to find 129. And it would be marked on here somewhere. So we can play more with some of these databases, and hopefully you've done that in some other classes. But I wanted you to know what that was talking about. And there are a couple of definitions. They're going to talk about iatrogenic and sporadic Creutzfeldt-Jakob. So iatrogenic is going to be a variation of the disease that's picked up from a medical procedure. and sporadic is basically sporadic, unknown source. There's another term in here, proband, where they're talking about the genealogies. Parents of the living, 127V probands. So when you create a genealogy, you start with a particular generation. That's your proband. That's where you started with. And then they go back in time to look at the parents of those starting individuals or probands. I think that's probably good enough. Oh, I didn't tell you about relative fitness. Let's look at relative fitness, and it happens to be right here, I think. Yes, relative fitness. Okay, so omega relative fitness here is going to be, well, they say the number of survivors of a genotype standardized to the most viable genotype. So a little more clearly said, the average number of offspring of the particular genotype of interest, this could be one of your variants, it could be a homozygote, and you're going to compare that average number of offspring for that genotype to the average number of offspring for some other genotype. The way you standardize it is you're going to select one of those as your standard and say that its fitness is just 1. Okay, so let's say we set fitness for instance, for any of the heterozygotes. Set those equal to 1, and then look at just 129 and see how they compare. So if you get a value of 1, then they are equally fit. If you get a value less than 1, your genotype of interest, we said 129, is less fit. And the smaller that number, the less fit it is. And then if you get it over 1, it's going to be more fit. So what did they find? Which of these genotypes was more fit? So you need to figure out the orientation, right? So what were they standardizing to, so that you can figure out if it's a less than number, what is it that is more fit? I hope that makes some sense there. Let's check and see if there are any other figures. Figures are always important. They've got a couple of figures showing you, heterozygotes, Hardy-Weinberg. I think you can figure that out. Pay attention to the p-values in this figure here. And I think you guys are going to be just fine with that. So come into class with those lists completed, because we're going to start from your notes. You'll need your paper, you need your lists, you'll need your message box, and we'll get started talking. See you in class.